In this video, we're going to look at how to find the zeros and multiplicity of zeros for polynomial functions. Using factoring, we should be able to find the zeros of the function, or let the function be equal to 0 and find the x values for which that is true. Let's look at this first example. I'm going to find the x-intercepts. Remember, the x-intercepts are the points x, 0, y equals 0, by setting this equation equal to 0. I'm then going to factor this, it doesn't have a special name, but polynomial of degree 6, I guess we could call it. I notice that there is a common factor of x squared. That leaves me with x to the 4th minus 3x squared plus 2. I then notice this as a sneaky quadratic, or a quadratic in sneaky form, if you will. If this was w squared minus 3w plus 2 equals 0, then two numbers that multiply to positive 2 and add to negative 3 would be negative 2 and negative 1. Therefore, instead of it being w squared, this is like x squared, and in place of w, x squared plus 2. So that means these factors would be x squared minus 2 and x squared minus 1. I now have a factored form. I know that this is going to be 0 when x squared equals 0, or when x equals 0. When x squared minus 2 equals 0. Now be careful, that means that x is equal to both plus and minus the square root of 2. And when x squared minus 1 equals 0, same. And so those are my x-intercepts. All right, let's look at another example. Here is a cubic function. We're going to find the x-intercepts again by factoring. So let's let our cubic function be equal to 0. This time I don't have a common factor and I have a cubic, but I think I can maybe do this by factor by grouping. Let's see if I can. I'm going to factor out an x squared for the first two terms, and I'm going to factor out a negative 1 for my second two terms. Second group, I guess my first and second term here, third and fourth term here. I then have x minus 5 as a common factor, and I'm left with x squared minus 1. So now I have this in factored form. That means x minus 5 could be 0, or x could be equal to 5. And x squared minus 1, 0, we already saw that that would be then plus or minus 1. Now that we've talked a little bit about finding the zeros, let's talk about multiplicities. Graphs have behave differently, at various x-intercepts. Sometimes you'll go straight across, sometimes you'll have a bounce. For example, if I have a polynomial in this factored form, this is the graph. If I let this be equal to 0, let's do the same thing that we just did above. So x could be -3. Notice that's a 0 of my graph. X could be 2. Notice it's not x squared minus 2. It's that I have 2 factors of x minus 2. And notice here with that multiplicity of 2, 2 factors at x minus 2, that this behaves like a quadratic function. Notice here I only had one term of x plus 3, and this behaved almost like how a line behaves at a 0. Let's look at our last one. So again, my inside piece at x equals -1, and then notice that this does a little like wiggle through it. And that's because it should behave like a cubic function at x equals -1. Let's use this graph of degree 6 to find the zeros and their possible multiplicities. So I'm noticing I have a 0 at x equals -3. I have a 0 at x equals -1. And I have a 0 at x equals 4. Well, in order for this to be equal to 0, I would add 3 over, add 1 over, subtract 4 over. And so I'm going to say that this function must be something, some a here in the front, I'm not quite sure, times these zeros. However, I don't have a degree of 6 when I have it like this right here. I would only have a degree 3. And you can't just put an x right here of degree 3 and say, well done, because I don't have a 0 at x equals 0. So I need to go back and think about the behavior at each one of these and what it might mean as far as the degree. Notice at x equals -3, I have a bounce. I bet that this has a multiplicity of 2, so my degree is probably 2. Through x equals -1, it just goes straight through without a wiggle, so I bet this has a multiplicity of just 1, which you don't have to write, but you can. Through x equals 4, notice the shape looks like a cubic function, so I think that this has a multiplicity of 3. All right, now let's check some number, and since I go up and up in behavior, I know a is positive. X squared for a leading term, x1 for a leading term, x cubed for a leading term, yes, x to the 6. So this is my possible function for this degree 6 polynomial.